All right. Our next lesson is we're going to continue using the unit circle, and you should already have filled out this table, at least some of it anyway. Let me go ahead and go through some of that. You should have 0 degrees right there. Let me do that, and then 60, and then 90. Don't worry about filling in this column right here, but you should be able to fill in and don't worry about the reference angle either. You should be able to fill out sine and cosine based on what we talked about in the last lesson. Remember, cosine is the x value on those coordinates, and sine is the y value. So you should have, at 0, you should have the cosine value is 1, and the sine value is 0, because it's 1, 0 there. And then at 30 degrees, the cosine value is square root of 3 over 2, and the sine value is a half. Okay, and so you should have that filled out. If you don't, you might want to take some time to do that because we're going to use this chart quite a bit to reference. What we're going to talk about today is tangent. How do we get tangent? So that's our learning target. Use a unit circle to evaluate the value of tangent at various angles. Okay, so let's talk about tangent. All right, if you remember when we were dealing with SOHCAHTOA, tangent was the ratio of the opposite side over the adjacent side. Okay, so let's carry this over into the triangles we've been talking about that we used to create the unit circle. Remember, the hypotenuse was a 1. All right, so if I looked at this 60-degree angle, the short side, the side that was across from the 30, because that's 60 and that's 90, all that's left is 30 degrees. The short side was 1/2. And the long side, the side that was across from the 60, was square root of 3 over 2. And again, we talked about how that was like 0.866, and we said the exact value was square root of 3 over 2. Okay, if you remember, we used this 60 when we put that corner at the origin. When we put this at 0, 0, okay, it made the circle touch, or this radius touch the circle, and we called that the 60-degree mark on the circle, and we said that its coordinate was the x value was a half, and the y value was square root of 3 over 2. Now let's talk about how this applies to tangent. If we're going to apply this to tangent, then tangent of 60 degrees is opposite. Which side's the opposite of the 60? Well, the opposite's right here. Square root of 3 over 2. And then over adjacent, and the adjacent side to the 60 is right here. Okay, now this is a nasty complex fraction. Again, we're trying to do this without a calculator, so I want to have you do something for me here. I want to have you chant something. I know it sounds strange, all right, but at least say it to yourself, say it quietly, because studies have shown that if you say something, you repeat it back, not only are you having to think physically, think about of what you're saying, but you're actually having a process going through that of saying it. So here's what I want you to say with me real quick. Dividing is the same as multiplying by the reciprocal. Okay, let's try it. Say that with me. Dividing is the same as multiplying by the reciprocal. Try it again. Dividing is the same as multiplying by the reciprocal. So what that means is this nasty complex fraction that we have right here, we can actually say that, no, we're dividing by 1/2. We keep the top part, we change to multiply, and we flip the bottom one over. That's the reciprocal. Okay? This concept, dividing is the same as multiplying by the reciprocal. The sooner you get that down, the easier the rest of the semester is going to get for you, because we're going to use that concept quite a bit. All right? So if we do that, okay, we multiply fractions by multiplying straight across. Remember, outside number, inside number don't mix. We call this 2 square root of 3. 2 times 1 is 2. And now we can reduce this number. Because I got 2 outside numbers that are 2's, they can cancel out, and I just get square root of 3. Okay, technically we get square root of 3 over 1, right? Because this is going to be canceled out. So there's still, we can say there's a 1 right there. But this turns into square root of 3. That's the tangent value. Okay, that's how we're going to use these coordinates to come up with the tangent values. Okay, the opposite side was the y, and the adjacent side, that was the x. We had square root of 3 over 2, that was the y, and the adjacent side was the x. So we can actually extend this further. When I talk about tangent, I can call this y over x. Or we can even make the connection back to the last lesson. If you remember, the sine value was the y value. So we could say that this is the sine over the cosine value. Okay. Now, we're going to do a couple more and see if we can't pick out a pattern. All right. All right. So we have tangent of 45. I want you to go back to your unit circle. Go to your unit circle and go find 45 and look at the coordinate. Okay, the coordinate at 45 was this: square root of 2 over 2, comma, square root of 2 over 2. No, that's not what I want. I'll get there. All right, so the coordinate is square root of 2 over 2 and square root of 2 over 2 at 45 degrees. Okay, so again, if I want to do tangent of 45, I'm going to do the y value over the x value. And I'm going to come up with square root of 2 over 2 over square root of 2 over 2. Okay, now don't think too hard on this one. What happens when you take something and divide it by the exact same thing? Something divided by the exact same thing should turn out to be 1. But let me go through the math. Remember that thing I had you chant. Dividing is the same as multiplying by the reciprocal. So we keep the top, change to multiplication, we flip the bottom one over, and if we carry it out, we get 2 square root of 2 over 2 square root of 2, and so hopefully more clearly you see that that's just going to be 1. All right, let's do another one. Tangent of 150. Again, I still want to use the unit circle. I'm trying to do all this stuff without a calculator. That's the goal. We want to be able to do this without a calculator. We get into, hopefully you get into taking calculus. The more familiar you get with some of these and writing these coordinates, the easier some of that's going to be, because you will deal with these trig functions in calculus quite a bit. So let's go look at 150, because that's what we're taking the tangent of. Here's 150. There's the coordinate. Let's write that down. Negative square root of 3 over 2, comma, 1/2. Okay. Tangent is y over x, opposite over adjacent. The y over the x. So I'm going to take the y value, which is 1/2, over the x value, which is negative square root of 3 over 2. Again, dividing is the same as multiplying by the reciprocal. Dividing is the same as multiplying by the reciprocal. So I'm going to flip that over. And it doesn't matter which one gets the negative sign. Okay, but I need to have one of them have a negative on it. All right, take a look. Multiply straight across. You get negative 2 over 2 square root of 3. All right, I want to reduce that. Now, if I go and cancel the 2's, and that's fine, but if I cancel the 2's, there's still got to be something up here. So I got to say that there's a 1 up here. 2 goes into 2 one time. So I'm going to put negative 1 over square root of 3. Okay, that's what we have. Now, if we want to finish it up, remember we don't like radicals in the denominator, so we got to give this guy a buddy. We got negative 1 square root of 3, which is just negative square root of 3, over, remember when they have a buddy, when you have a pair of numbers under the radical, that creates a perfect square that you can take the square root of. Okay, this becomes square root of 9 when you multiply those two things together, and then square root of 9 is 3. Okay, so that's what we're going to fill in on our unit circle table for tangent of 150. So I can go down to the 150 and I can fill in the tangent of that as negative square root of 3 over 3. Okay, so you want to kind of do this as you go. All right, now let me show you a shortcut. Let me see if you can pick it up. All right, notice what we ended up with right here. Okay, Let's compare that to our coordinate that we started with. Let's compare it. Take a look. Right? We set up a y over x, but really, what did we end up only needing out of this? If you look, we really only needed those numerators, the y numerator over the x numerator. We then had to rationalize this to finish it off, but that's what we ended up with right here. You understand why we only needed the numerators? Look what happened to these 2's. What's going to happen to the 2's is they're going to end up canceling out. Okay, what's going to happen to the 2's over here? They ended up canceling out. Let me back it up to the previous one, the one I started off with. Look what happened to the 2's. They ended up canceling out. So we really only needed numerator over numerator. So when we say that tangent is y over x, the shortcut on our unit circle is to say it's the y numerator over the x numerator. Okay? All right. That's what we're going to end up doing. So I can go pick out one of these and say, hey, what's tangent? What's tangent at 210? Let's look at 210. Y over x. Tangent is y over x. That y numerator over the x numerator. So tangent at 210, we can say, is negative 1 over negative square root of 3. Well, negative divided by negative is going to be a positive. And we don't like the radical in the denominator, so it's just going to be square root of 3 over 3 once we give this guy a buddy and rationalize it. Give it a buddy, rationalize it, negative over negative is going to make it positive. Okay. What about tangent of 315? Here's 315. Tangent is y over x. So tangent of 315, y numerator over x numerator. So I get negative square root of 2 over square root of 2. And again, if I got the same thing on top and bottom, it's going to make it 1, but it's going to be a negative 1 because of that. So it's just negative 1 there. Okay, now there's a couple other ones I want to talk about. A couple other situations here, and you already saw them. Okay, what about at 180? Okay, what about at 180? So at 180, go back and look. Let me clear all this stuff out so it's not in the way. Okay, let's go to 180. What do we want to do with 180? Remember, tangent is y over x. Okay, so the coordinate is negative 1 comma 0. Negative 1 comma 0, and tangent is y over x. The y value is 0. The x value is negative 1. What do you get when you take 0 divided by negative 1? You started with 0, you divide it up, you still got 0. Okay, so anytime 0 is in the numerator, you get 0 as an answer. But what about at 270? Let's look at 270. Okay, look at the coordinate at 270. Now the coordinate at 270 is 0 comma negative 1. Keep doing that. 0 comma negative 1. Is it going to be the same? Again, tangent is y over x. Now I have negative 1 over 0. Are we allowed to divide by 0? Can anything get divided by 0? No, try it. If I just try this and clear this out and take negative 1 divided by 0, you're not allowed to divide by 0. So if 0 is in the denominator, we're going to write undefined. Okay, so now you have everything you need to go through and fill out your tangent. Really, all you need are these sine and cosine values, right? Because sine was y, cosine was x. So if I look at 30 degrees, I'm going to take the 1 over the square root of 3. Remember, the 2's are going to end up cancel out when we remember that dividing is the same as multiplying by the reciprocal. Now, we don't like those radicals in the denominator, so if we rationalize it, it turns into square root of 3 over 3. You should give that guy a buddy. Okay, so finish out filling this tangent column, and then you'll be ready to work the quiz out in class tomorrow. All right, you guys have a good day.